Hi students, welcome to Sunil's tutorial. I am Sunil Milwani and today we will be doing this chapter called as application of integration. Take down the sum please. Find the area of the region lying above the x-axis and included between the circle x square plus y square is equal to 2ax and parabola y square is equal to ax. Right, now let's try to see how the figure would be. We are saying that it is above the x-axis, that means it has to be in the first quadrant. Circle, parabola, right? The equation of parabola is given to you as y square is equal to ax. The equation of circle is given to you as x square plus y square is equal to 2ax. You have to find out the area of the region lying above the x-axis and included between the circle and parabola. That means you have to find the area of this region. Right? Above x-axis and between the circle and the parabola. Fine, do we get this thing here? Now, since this is the region, let's call this point as say P. Right? I can say since the circle and the parabola intersect each other, I can substitute the equation of one in the other. Now, equation of parabola is given to me as y square is equal to ax. Equation of circle is x square plus y square is equal to 2ax. Now I can substitute the value of y square from equation of parabola into the equation of circle, right? So if I substitute 1, 2, substitute 1 in 2. If I substitute 1 in 2, I'll get x square plus ax is equal to 2ax, right? In which case I will get x common, x plus a is equal to 2ax. So in which case you will get this and this gets cancelled. So in that case you will get x plus a minus 2a is 0, x minus a is 0. So in which case I can say that x is equal to a, right? Once I get the value of x as equal to a, I can substitute the value of x in any one of the equation and get the value of y. So in that case I can say that, therefore I can say that y square is a into a, therefore I can say y square is equal to a square, y is equal to plus minus a, right? Now once you have this, I know the x-intercept and y-intercept. That means the coordinates of point P in the first quadrant will be a comma a. Its x coordinate is a and its y coordinate is also a. Both the coordinates of it are a. So I can drop a perpendicular. Let us assume that PS is the perpendicular on x-axis. Right? Let us assume let PS be the perpendicular. Let PS be the perpendicular on x-axis. Right? Now, in that case, I can therefore say that S is going to be equal to a comma 0. Since it is a perpendicular drawn from P, the x coordinate of P and the x coordinate of S should be the same, right? Now let's find out area of Let's label this up, guys. Let's call this point as say R, and let's call this point as say Q, right? So let us assume that let's find the area of OSPRO. That's the section of the circle, right? Right? Now area of the circle is area of any part. A curved surface is integral of y dx from lower limit to upper limit. The lower limit is going to be 0 origin. The upper limit is going to be a because the coordinates of S are a, right? But for the circle x square plus y square is equal to 2ax, I can say that y square is 2ax minus x square. Therefore y is square root of 2ax minus x square. Therefore I can say that area of OSPRO is integral of 0 to a square root of 2ax minus x square with respect to x. This is quadratic. X square means quadratic. In that case I need to find out the last term. Last term is given by the formula middle term into middle term upon 4 times first term. So that is 2ax into 2ax upon 4 times x square. This is going to be a square. Let's call this area as a1. So a1 is integral of 0 to a square root of, now observe this carefully guys, I'll take minus sign common, so this will become x square minus 2ax, right? Add a square, that means in reality I'm subtracting a square because plus into minus is minus. Subtract a square, add a square with respect to x, right? So this is going to be integral of 0 to a square root of a square minus x minus a the whole square with respect to x, right? This is in the form a square minus 2ab plus b square, right? Now once you have this, then you can say that okay, now integral of a square minus x square is nothing but a1 is nothing but x by a x by 2 integral square root of a square minus x square, that is 2ax minus x square, because a square minus x minus a the whole square, I got it actually from 2ax minus x square. So I'll skip that step and I'm showing you directly. Plus a square by 2 sine inverse of x by a when the limits are between 0 to a. Fine, do we get this in clear? I'm using your normal integration formula. Now, how do I solve this? Upper limit minus lower limit. So this is a minus a by 2 square root of 2, substitute, so 2a square minus a square plus a square by 2 sine inverse of a minus a by a, right? Minus, this was upper limit, minus lower limit. So in that case that will be 0 minus a by 2 square root of 0 minus 0 plus a square by 2 sine inverse of 0 minus a by a, right? A minus a is 0, so this whole term will become 0. This is a square by 2 sine inverse, a minus a is 0, so that means this term will also become 0, minus a by 2 into 0, square root of 0 is 0, plus a square by 2 sine inverse of minus 1, right? So in that case, this is going to be, this term will also be 0. So this is a square by 2 minus a square by 2. Sine inverse of 1 is 90. So sine inverse of minus 1 will be minus 90 minus pi by 2, minus into minus plus. So this is a square by 2 into pi by 2. So the area of that region is going to be therefore a square pi a square by 4. Now let us try to find the area of OSPQO. That's your area of the parabola, right? Integral of 0 to a y dx, right? Let's call this area as A2. Now for the parabola, before that I can say that, but for parabola I can say y square is equal to ax, therefore I can say y is equal to root ax. Therefore I can say that A2 is integral of 0 to a root ax dx, right? In which case I can say A2 is root a is constant, comes out, integral of 0 to a x raised to 1 by 2 dx. Root x can be written as x raised to 1 by 2, right? So this is nothing but root a x raised to 1 by 2 is x raised to 1 by 2 plus 1 upon 1 by 2 plus 1 when the limits are between 0 to a. So this is going to be root a x raised to 3 by 2 upon 3 by 2, right? So this is going to be when the limits are between 0 to a. So this is going to be root a 2 root a by 3 a x raised to 3 by 2 when the limits are between 0 to a. Now upper limit minus lower limit. So this is 2 root a by 3 a raised to 3 by 2 minus 0 raised to 3 by 2. So this is going to be 2 root a by 3 a raised to 3 by 2 is nothing but a root a minus 0. So this is going to be root a into root a is a into a square. So this is 2a square by 3, right? Therefore I can say that area of shaded portion is the area of the portion in the circle minus the area of the portion in the parabola. So this is going to be pi a square by 4 minus 2a square by 3, right? In which case you will have a square common, pi by 4 minus 2 by 3 a square units. That will be the area of the region between the circle and the parabola. Fine, do we get this in here? Let's see another sum of this kind, guys. Find the area of the region. Find the area of the region bounded by the parabola y is equal to x square and the line y is equal to 4x. Okay, now let's see this. Let's try to see the figure. Now they have said that find the area of the region bounded by the parabola y is equal to x square and line y is equal to 4x. Now if the equation of the line is y is equal to 4x, that means it has to be a line passing through the origin, right? Do we get this thing clear? So let's see this. I need a parabola. So what we will do is, let's just draw any parabola for the timing. Right? This is my parabola that is passing through the origin. So let's assume that the equation of this parabola is y square is equal y, x square is equal to y. right? Since it is x square is equal to y, it has to be a parabola that's along the y-axis, right? And I need a line that is passing through the origin. This is that line passing through the origin. Equation of this line is y is equal to 4x. They said that find the area of the region bounded by the parabola and the line. That means I have to find the area of this region. Right? Do you understand this? Okay. Now, let's see this. I can say that equation of line is y is equal to 4x, and equation of parabola is x square is equal to y, right? So in that case I can substitute the value of y. I can substitute y from equation 1 in equation 2. This is equation 1, equation 2. Substitute 1 in 2. So I'll get x square is equal to 4x. X square minus 4x is 0. X minus 4 is 0. Either x is equal to 0 or x is equal to 4. Right? When x is equal to 0, substitute the equation in any substitute the value of x in any one of the equation. So in that case, let's say that y is equal to 4x, therefore y will be 0. When x is equal to 4, y is equal to 4x. So in that case I can say that y is equal to 16. That means if I drew the figure again here, the point of intersection P, coordinates of P are going to be, there are 2 points of intersection, so therefore I can say O is 0, 0, that's my first point of intersection, and P is 4, 16. Right, those are going to be my 2 points of intersection. First thing I need to know is my points of intersection. Right, once I have this, then I can drop a perpendicular here. Right, let's call this as S. So you'll say let PS be perpendicular to x-axis. Now, if PS is perpendicular to x-axis, then I can say that length, or I can say S is equal to 4, 0, because it will have the same coordinate, x coordinate as P, as it has been drawn perpendicular. So this will be 4, 0. P is 4, 16. Right? Do we get this thing here? Similarly, I can say that therefore length OS is equal to 4. If the coordinates of S are 4, 0, that means length OS has to be 4. Similarly, I can say that length PS is going to be 16. Right, the perpendicular distance is 16. Since I know this, I can find out area of triangle OPS. Area of triangle is nothing but half base into height, OS into PS. So half base 4 into height, 32 square units. Right? So I found the area of the triangle. Now I need to find out the area of the sector. Let's call this as say R. Now I need to find out area of the sector OSPRO. OSPRO. Right? Area of a curved region is nothing but integral of y with respect to x from lower limit to upper limit. Its lower limit starts from the origin, its upper limit is up till point S, so up till point 4. Right? But for the parabola, they have given you that y is equal to x square. So in that case I can call this area say as A2. A2 is integral of 0 to 4. Instead of y I can write x square with respect to x, right? So in that case this is going to be nothing but x cube upon 3 when the limits are between 0 to 4. So this is going to be 1 by 3 4 cube minus 0 cube 1 by 3 64. So that is going to be 64 by 3, right? In that case guys, the area of the shaded portion, this region, the area of shaded portion is going to be nothing but the area of the triangle minus the area of sector. So that is going to be area of triangle was 32 square units minus 64 by 3. This is 96 minus 64 by 3 to 32 by 3 square units, right? That's going to be my area of the shaded portion. Fine, do we get this in clear? Next, let's now see how do we find the volume of a particular region, right? Let's see another sum, guys. Find the region bounded by x square plus y square is 25 when x is equal to 0 or x is equal to 3 revolved around the x-axis. Revolved around x-axis. Find the volume. Find the volume of the solid. Okay, find the volume of solid of revolution. Right? I need to find they give me equation. They are saying that it has been revolved around x-axis. So guys, this x square plus y square is equal to 25 is the equation of a circle. Now, let's try to visualize this. Let's assume that this is a circle. Okay, I'm going to revolve it. This is two-dimensional. I'm going to revolve it around its x-axis. Right? I'm going to revolve it completely around its x-axis. Right? I'm going to get a solid object, a three-dimensional solid object. Whenever you have a two-dimensional object revolved around its x-axis, you will get a solid three-dimensional object. In this case, it's going to be a sphere. If I revolve a circle around its x-axis, what I will get is a sphere. Fine. Now, they are asking you to find the volume of the sphere. Now, like when we were doing area, the area of any curved object was integral of y with respect to x. Similarly, you can say that the volume of any object is nothing but pi times integral of y square with respect to x. So I can say that straight away. First, let's find out the limits. I can say equation of the curve. Equation of the curve is nothing but x square plus y square is 25. Therefore, I can say that y square is 25 minus x square. Right? Now, they have also given me the limits of integration. Limits of integration are given to me. Lower limit is given to me as 0 and upper limit is given to me as 3. Right? Volume of any curve is given by the formula pi times integral of a to b y square with respect to x. That's how you find out the volume of a curve figure, right? So in that case, this is going to be pi times 0 to 3, 25 minus x square with respect to x right? In that case, this is going to be nothing but split pi times integral of 0 to 3 25 with respect to x minus integral of 0 to 3 x square with respect to x. Whatever is constant comes outside the integral, so this is going to be pi times 25 integral of 0 to 3 with respect to x minus integral of 0 to 3 x square with respect to x. Pi times 25 integral of dx is x when the limits are between 0 to 3. Integral of x square is x cubed by 3 when the limits are between 0 to 3. Right? So in that case, this is going to be nothing but pi times 25, 3 minus 0 minus 1 by 3, 27 minus 0, upper limit minus lower limit. Right? Do we get this thing clear? So in that case, you will get this as pi times 75 minus 9, so that's 66 pi cubic units. That is going to be the volume of the given solid figure. And do we get this thing here? That's how you find the volume. Next, let's see another sum. Find the volume of the solid generated. Find the volume of the solid generated by revolving the region under the curve under the curve the equation of the curve is given to you as x square upon 4 minus y square upon 9 is equal to 1 in the interval 2 to 4. In the interval from 2 to 4 about x-axis. Right? Let's see this. How do we do this sum? Now, they are saying that equation of the curve. Equation of curve is given to you as x square upon 4 minus y square upon 9 is equal to 1, right? In which case I can therefore say that x square upon 4 minus 1 is y square upon 9. Cross multiply 9 times x square minus 4. 9 upon 4, x square minus 4 is equal to y square. Let's leave that there. Limits of integration. Limits of integration are given to you as lower limit is given to you as 2, upper limit is given to you as 4. So in that case, I can find out the required volume. Required volume is integral of pi times integral of lower limit to upper limit y square dx, right? So in that case, you can say that this is nothing but pi times lower limit is 2, upper limit is 4. Y square is nothing but 9 by 4 x square minus 4 dx. Constant goes out. In that case, you will have 9 pi by 4 integral of 2 to 4 x square dx minus integral of 2 to 4 dx. Right? This can be written as 9 pi by 4. This is x cubed by 3 when the limits are between 2 to 4 minus 4 times integral of dx is nothing but x when the limits are between 2 to 4. So in that case, this will be 9 pi by 4. This is upper limit minus lower limit. So upper limit 64 minus lower limit 8. I'm substituting the value of x first with upper limit, then I'm substituting the value of x with lower limit. Minus 4 times 4 minus 2. Right? So in that case, this is going to be 9 pi by 4. This is 1 by 3 56 minus 4 into 2, right? This can be written as 9 pi by 4. This is 56 by 3 minus 8, right? So in that case, this is going to be 9 pi by 4, 56 minus 24 by 3, right? 3 ones are, 3 threes are. So this is going to be 3 pi by 4, 56, 2, 32, right? 8s are. Answer is 24 pi cubic units. So the volume of the figure will be 24 pi cubic units. Right? Next, let's see another sum, guys. Find the volume of a sphere of radius r. Now I want to find the volume of sphere of radius r. Now how do I do that? How do I actually generate a sphere? A sphere is nothing but a circle rotated about its x-axis. So let's draw this, guys. I have this circle, coordinate system, x-axis, y-axis. Now if I rotate the circle about its axis, now they are saying that radius is r. That means I can say that point A will have coordinates r comma 0 and point B will have coordinates minus r comma 0, right? Since the radius is r, I'm going to rotate this. How do I show that rotation? I'm going to show it to you this way. I'm rotating the whole thing about x-axis, right? Now if I rotate it about x-axis, only then I'll get a sphere. A circle rotated about x-axis gives you a sphere, right? So I can say that a sphere of radius r can be considered as a solid obtained by revolving about the x-axis the semicircle x square plus y square is equal to a square. This is a circle, this is the equation of the circle in center radius form where the center is origin, right? Now, either I call it circle or semicircle. Semicircle because then that will give me an exact sphere. If I say a circle, then in that case I'll have a double image form, right? Now, equation of the circle, although we say semicircle, I'm still going to consider equation of circle is x square plus y square is equal to a square. Therefore, I can say y square is equal to a square minus x square, right? Now let's find out the limits of integration. Limits of integration, right? The lower limit is going to be minus r and the upper limit is going to be r, right? Do we get this thing clear? Now, in that case, volume is nothing but pi times from lower limit to upper limit y square dx. That's the volume of a figure. So in that case, I can say pi times from minus r to r. Y square we found out is nothing but a square minus x square with respect to x, right? Now, let us assume, let's call this as equation 1 and leave this here. let us assume let f of x be equal to a square minus x square. Right? In that case, what will be f of minus x? Wherever there is x, you will substitute the value of x as minus x. Wherever there is x, you have to substitute x as minus x. Right? So in that case, I'll get this as a square minus x square. So I'll get f of minus x. A square minus x square is nothing but f of x. A square minus x square is nothing but f of x. Why should it be a? I'm substituting x as minus x. So minus x the whole square should give me plus x square. So I'll get f of minus x is equal to f of x. Hence, I can say that f of x is an even function. If f of x is an even function, we have a formula in definite integrals. If you remember that, integral of minus a to a, if I use this formula, I'll write that using the formula. You have this formula, integral of minus a to a, f of x dx is nothing but twice integral of 0 to a, f of x dx if the function is even. If the function is even, then from minus a to a, f of x dx is twice 0 to a, f of x dx. So in that case, let's continue with the sum now. I can say therefore, volume is going to be, instead of writing from minus r to r, I can write from 0 to r if I use this formula. Right? So this is going to be pi times 2 into 0 to r a square minus x square with respect to x. Right? Now, once you have this, then you can solve the equation. So in that case, I can say that this is 2 pi 0 to r. This is going to be a square with respect to x minus 0 to r x square with respect to x. Right? So in that case, a square is constant comes out. So this is 2 pi a square integral of dx is nothing but x when the limits are between 0 to r minus x square is nothing but x cube by 3 when the limits are between 0 to r, right? In which case you will get this as 2 pi as it is. 2 pi as it is. This is a square upper limit minus lower limit minus 1 by 3 upper limit minus lower limit r cube minus 0. Right? This is 2 pi a square r minus r cube by 3. Right? But in the equation of circle, x square plus y square is equal to a square. A square represents the radius of the circle. Right? In this equation, x square plus y square is equal to a square. What is a square? A square is the radius of the circle. Therefore, I can say that a square is nothing but equal to r square. If a is the radius, that means a square will be equal to r square. In which case, therefore, I can say that volume is 2 pi. Instead of a square, I can write r square into r minus r cube by 3. So this is 2 pi r cube minus r cube by 3. 2 pi 3r cube minus r cube by 3. 2 pi 2r cube by 3. 4 pi by 3 r cube. Therefore, the volume of the sphere is going to be 4 by 3 pi r cube. Fine, do we get this thing clear? This is how you derive the volume of the sphere. Fine, do we get this thing clear? Okay, we'll stop this here for the day. Thank you very much.